This video discusses solving rational equations. We present a procedural outline for solving these equations and then illustrate with 4 specific examples. Let's first consider a definition. A rational equation is an equation that involves one or more rational expressions. For example, any equation involving fractions is a rational equation. However, a rational equation usually refers to an equation with variable quantities in the denominators of the fractions. Note, in the third example, the fractions involved in the equation might be rather complicated. As is often the case, a general process guideline is helpful in solving rational equations. First, factor the denominators of all rational expressions. Second, identify and list all restricted domain values in the original equation. Then find the least common multiple of the denominators from the equation and multiply on both sides of the equation by this least common multiple found in the previous step. This will clear all fractions from the equation. Next, solve the resulting polynomial equation. And finally, check for extraneous solutions. An extraneous solution is a solution that results from the algebra, but is not an actual solution to the original problem. Typical types of extraneous solutions are answers that either make some expression undefined or don't make sense in a particular application. For example, a value that makes the denominator equal to 0 or a negative length in an application problem would be an extraneous solution. Let's consider 4 specific examples using this process. Solve the equation x over 6 minus x over 8 equals 1 over 12. We begin with our original equation. The least common multiple of denominators 6, 8, and 12 is 24. So we multiply both sides of the equation by 24. Next, we distribute 24 on the left-hand side of the equation. Notice that we've multiplied by 24 in order to clear all fractions, so each resulting fraction will reduce nicely, resulting in a polynomial equation. Solving this polynomial equation, we get that x equals 2. A check in the original equation confirms that x equals 2 is a solution to the equation. Let's consider a second, slightly more complicated example. Solve the equation x plus 8 over x equals 9. We begin with the given equation and note the restriction that x cannot equal 0. If x equals 0 is a value produced by our algebra, we will omit this as an extraneous solution. We multiply both sides of the equation by x, the least common denominator, to clear all the fractions. Notice when we distribute x on the left-hand side, we get a quadratic equation. To solve quadratic equations, we put the equation in standard form and hopefully factor the quadratic. Since x squared minus 9x plus 8 factors as x minus 1 times x minus 8, we have a product equaling 0. Therefore, one of the factors must equal 0, giving us 2 easy linear equations to solve. We get that x equals 1 or 8. Since neither of these are restricted values for the original equation, they are both solutions. Now let's solve a much more complicated rational equation. we will rewrite our given equation with factored denominators. We substitute x minus 3 times x minus 4 for the quadratic x squared minus 7x plus 12 in the original equation. This form makes it easy to identify the restricted values. X cannot equal 3 or 4. We can also determine the least common multiple of the denominators when the denominators are in factored form. We multiply both sides of the equation by the least common denominator of x minus 3 times x minus 4. Notice that distribution of this quantity clears all fractions from the equation. On the left-hand side, we get 6 plus 2x times x minus 4 after distributing. And on the right-hand side, we have 3x times x minus 3 after canceling our x minus 4. We can simplify both sides more to get 6 plus 2x squared minus 8x equals 3x squared minus 9x. And we notice that this is a quadratic equation. We can put the quadratic in standard form by subtracting 2x squared, adding 8x, and subtracting 6 on both sides of the equation. Since x squared minus x minus 6 factors x minus 3 times x plus 2, we again have a product equaling 0. Therefore, one of the factors must equal 0. We get that x equals 3 or x equals negative 2. However, from the listed restrictions, we know that x equal 3 is extraneous, and therefore x equal 2 is the only solution. Finally, let's solve the equation x squared over x minus 1 equals 1 over x minus 1. Let's first note the restriction that x cannot equal 1. Then multiply both sides of the equation by x minus 1 to clear the fractions. We get the quadratic equation x squared equals 1. We can write this equation in standard form by subtracting 1 from both sides. Factoring x squared minus 1 via the difference of squares formula gives us a product equaling 0. Therefore, one of the factors must equal 0. We get that x equals 1 or minus 1. However, from the restricted values, we know that x equal 1 is extraneous, and therefore x equal negative 1 is the only solution to the equation.